Today we will be talking about normality. Okay, for normality there is a equation for it or formula for it. It is n is normality is denoted by n. Okay, so n is equals to gram equivalent of solute divided by volume of solution in liter. You have to by heart this formula. So, normality is equals to gram equivalent of solute divided by volume of solution in liters. Okay, so let's talk about what is gram equivalent of solute. I'll be coming to the point key what exactly normality means. For understanding that, we have to know what is gram equivalent of solute. Okay, so gram equivalent of solute says gram equivalent that says molecular weight of acids of or base anything divided by the number of replaceable H plus or OH minus. Okay, so the formula for gram equivalent is molecular weight of that particular acid or base of our interest, like for what acid or base we are calculating the normality. We have to know the gram equivalent of that particular acid or base first of all, and for knowing the gram equivalent of that particular acid or base, we have to know the molecular weight of the particular acid or base. Okay, let's take an example of an acid that is the king of chemicals, that is H2SO4. It has a molecular weight of 98 grams per mole, if I am not wrong. Okay, so the gram equivalent of H2SO4 is equals to 98, and you have to see H2SO4 has 2 hydrogen plus ions in it. Okay, so 98 divided by number of replaceable H plus ions or H minus ions, that is 2 for H2SO4. It comes 49. Okay, this is the gram equivalent of H2SO4. And for normality, we talked about normality formula, right? So for normality equals to gram equivalent of solute divided by volume of solution in liters. Okay, so we have 49 grams of H2SO4, that is the gram equivalent of H2SO4. We got this one. So for one normal H2SO4, this will come around 49 grams, like the gram equivalent for it, divided by 1 liter of volume. Okay, so what we are getting from all of this, one normal H2SO4 means 49 grams of H2SO4 powder in 1 liter. Here is this volume. The volume is here a particular solution. Okay, in 1 liter. So the solution for this is deionized water. So one normal H2SO4 means 49 grams of H2SO4 in 1 liter of deionized water. You got my point? Now if we calculate one normal NaOH, Na has 23, I guess, O 16 plus 1, that comes with 40 grams per mole. Okay, so this is the molecular weight actually, and if we see the gram equivalent of NaOH has only one OH minus. Okay, so number of replaceable OH minus ion is only one for this case, but we saw the case for H2SO4, that was 2 H plus ions for H2SO4, 2 H plus replaceable ions, so that was divided by 2 for gram equivalent calculation for this case H2SO4. Okay, for this case it will be 40 only, there will no change, so the normality will be equals to 40 divided by 1 liter of volume. So this comes around that means one normal NaOH means 40 grams of NaOH beads in deionized water. Did you get my point? Okay, so this is done. Now we'll have to enter to the next topic, that is dilution law. Okay, so there is a formula you have to remember for this, for dilution law, that is N1V1 is equals to N2V2. From this equation, like we understand that A normality is inversely proportional to the V, that is volume of the solution. Okay, so this says N1, for this equation I will like talk first. N1 is the initial normality. Okay, this is the initial volume. This is the final normality, and this is the final volume. If a question comes on this topic, the dilution law, and they say like prepare 250 ml of 0.1 normal HCl from 1 normal HCl, how will you make this in your chemistry lab? So first of all, we have to check what is given in this question. 250 ml, we have to make 0.1 normal HCl solution. We have to make 250 ml 0.1 normal HCl solution. So this is the final thing we have to made, and this is we have to make this from this 1 normal solution, 1 normal HCl solution. So N1V1 is equals to N2V2. So this was the initial, like whatever you can take. If initial is given 1 normal HCl only given, there is no volume given, so I will take it V1 only, and we have to make 0.1 normal of HCl into volume, that is 250 ml. Okay, so what we get? We get the value of V1 will be equals to let's do this, 0.1 250 divided by 1, so this comes to 25 ml. Okay, so what we have to do is V1 is 25 ml, N1 is 1 normal, so V2 was 250 ml, N2 was 0.1 normal. We will have to take 25 ml of 1 normal HCl in a volumetric flask. Okay, so volumetric flask looks like this, or you can take a beaker also. Okay, you can take a volumetric flask, add 25 ml of 25 ml of 1 normal HCl in it. Okay, and then add 250 minus 25 ml, that is how much, 225 ml of water, distilled water. Okay, you will have to add 25 ml of 1 normal HCl in this volumetric flask plus 225 ml of distilled water in it, and you will be getting 0.1 normal HCl of a solution of 250 ml. Thanks for watching this video, guys. Let me know if you have any queries. Bye.